Hello, good day. Now we are going to explore on the evolution of total quality management. What is total quality management? It's meeting quality expectations as defined by the customer. Integrated organizational effort designed to improve quality of processes at every business level. Now we can define quality in 5 ways. One way is through conformance to specifications, in which we should ask the question, does product or service meet targets and tolerances defined by designers? Second way to define quality is through fitness for use, in which one evaluates performance for intended use. Another way to define quality is through the value for price paid, wherein here there is a comparison on the evaluation of usefulness against the price paid. Another way of defining quality is through the support services, which is the quality of support after sale. You can also define quality through psychological way in terms of the ambience, prestige, or friendly staff. Now, what's the difference between manufacturing quality and that of service quality? Manufacturing quality focuses on tangible product features such as conformance, performance, reliability, features, durability, and serviceability. While for service organizations, produce intangible products that must be experienced. Therefore, quality often defined by perceptual factors like courtesy, friendliness of staff, promptness in resolving complaints, atmosphere, waiting time, and consistency. Now let us try to look into the dimensions of quality for manufacturing against that service organizations. For manufacturing, try to find dimensions of quality: conformance to specifications, performance, reliability, features, durability, and serviceability. While for service, the dimensions of quality are the following: tangible factors, consistency, responsiveness to customer needs, courtesy or friendliness, timeliness, promptness, and atmosphere. Quality and practice. Motorola and GE, or General Electric, attribute their success to having one of the best quality management programs in the world. Six Sigma was implemented. Levels of defects is reduced to 3.4 parts per million. Everyone is trained in quality improvement principles and techniques. And black belts, their full-time job is to identify and solve quality problems. Cost of quality. Quality affects all aspects of the organization and have dramatic cost implications. Most obvious consequence of poor quality is that dissatisfied customers and eventual loss of business. Prevention costs is the cost of preparing and implementing a quality plan. Operational cost is the cost of testing, evaluating, and inspecting quality. Internal failure cost is the cost of scrap, rework, and material losses. External failure cost is the cost of failure at customer site, including returns, repairs, and recalls. External failures can sometimes put a company out of business almost overnight. External failure costs tend to be particularly high for service organizations. Here is a graph of cost of defects. We have there in the y-axis the cost of defect, and for the x-axis the location of defect. And we have seen the curve there. Now the evolution of total quality management or TQM. Early in the 20th century, quality meant inspection, reactive in nature. In 1980s, quality began to have strategic meaning, that means proactive in nature. Successful companies understand that quality provides a competitive advantage, put customer first, and define quality as meeting or exceeding customers' expectation. Quality excellence has become a standard for doing business. Here's the summary of the evolution of total quality management, okay, with its new focus now. Okay, we have here the time and also its corresponding focus. In early 1900s, it's more focused on inspection, while in the 1940s, its focus is more on statistical sampling. In 1960s, its focus is more on organizational quality focus. While in 1980s and beyond, it's more focused on customer-driven quality. As we can see from early 90s to 1960s, this is the old concept of quality, that is, inspect for quality after production, or for 1980s and beyond, here comes the new concept of quality, which build quality into the process, that is, identifying and correcting causes of quality problems. Now we have here quality gurus. Say, for example, Walter A. Shewhart on 1920s and 1930s. He was considered to be the grandfather of quality control, and he contributed to understand the process of variability, and he developed concept of statistical control charts. While in 1940s and 1950s, we have W. Edwards Deming, is the founder of quality control. He stressed management's responsibility for quality. He developed 14 points to guide companies in quality improvement. Japanese established a Deming Prize in his name. 15% of quality problems are actually due to worker error, and 85% of quality problems are caused by systems and errors. On 1950s, we have this quality guru, the person of Joseph M. Juran. He defined quality as a fitness for use. He developed concept of cost of quality and originated the idea of quality triology, which are the following: quality planning, quality control, and quality improvement. In the 1960s, we have Armand V. Feigenbaum. He introduced the concept of total quality control. In 1970s, we have Philip B. Crosby, another quality guru who defined or coined the phrase quality is free. He introduced the concept of zero defects and developed the phrase do it right the first time. Another quality guru was Kaoru Ezekawa. He developed cause and effect diagrams, identified concept of internal customer. He introduced the concept of quality circles. Another quality guru was Genichi Taguchi. He focused on the product design quality, and he developed Taguchi loss function. Cost of quality increase as a quadratic function as conformance values move away from target. Robust design, a design that results in a product that can perform over a wide range of conditions. Here's the traditional view of the cost of conformance. All right, so loss, no loss, then loss. Taguchi view of the cost of non-conformance. Okay, here's the Taguchi loss function as is illustrated here. We have a curve in terms of the target, 5.0 tolerances, 4 to 8.4, 80 to 0.520. A total quality management philosophy, what's different? Total quality management attempts to embed quality in every aspect of the organization. Focus on customer, identify and meet customer needs, stay tuned to changing needs, for example, the fashion styles. Continuous improvement, continuous learning and problem solving, that's defined by Kaizen or the Six Sigma. Quality at the source, which means inspection against prevention and problem solving. Employee empowerment, empower all employees, external and internal customers, team approach, and quality circle. Understanding quality tools, ongoing training on analysis, assessment, and correction, and implementation of quality tools. Team approach, teams form around processes to 8 to 10 people, meet weekly to analyze solve problems. Benchmarking, studying practices at best-in-class companies. Managing supplier quality, that is certifying suppliers versus receiving inspection. 4 dimensions of quality. First is quality of design, determining which features to include in the final design. Quality of conformance to the design. Production processes are set up to meet design specifications. Another dimension of quality is ease of use. Instructions, operation, maintenance, and also safety. Post-sale service, another dimension of quality, which can be defined through responsiveness, rapid repair, and of course, spare parts. Cost of quality, there are actually four categories. You have the prevention cost, which is the cost of preparing and implementing a quality plan. Appraisal cost, cost of testing, evaluating, and inspecting quality. Internal failure cost is the cost of scrap, rework, and material losses, while external failure cost of failure at customer side, including returns, repairs, and recalls. Early detection, for instance, is less costly, maybe less by a factor of 10. Ways of improving quality, you can make use of what we call PDSA, or that's the Plan, Do, Study, Act cycle, also called the Deming Wheel after its originator, Deming. Circular, never-ending problem-solving process. Another way of improving quality is through quality function deployment, which is used to translate customer preferences to design. And we have 7 tools of quality control. These are tools typically taught to problem-solving teams. Okay, PDSA details, we have plan, evaluate current process, collect procedures, data, identify problems, develop improvement plan, performance objectives. We have do, implement the plan on a trial basis, study, collect data, and evaluate against objectives. We have act, communicate the results from trial. If successful, implement the process. PDSA cycle is repeated after act phase, start planning, and repeat process. Quality function deployment, a tool used to translate the preferences of the customer into specific technical requirements. Quality function deployment begins by identifying customer requirements coming from marketing department. These requirements are numerically scored based on their importance, and scores are translated into specific product characteristics. Comparison of product is made with its competitors relative to identified characteristics. The specific goals are set to address identified problems. The resulting matrix looks like a picture of a house and is often called the house of quality. Customer requirements survey customers to find out what they specifically need in our product. We do focus groups, telephonic interviews, directly talk to customers. Competitive evaluation, how our product compares to those of competitors. Evaluation scale is from 1 to 5. Higher the rating, the better. Product characteristics. Specific product characteristics are on top of relationship matrix. The relationship matrix, the strength of relationship between customer requirements and product characteristics is shown in the relationship of matrix. A negative relationship means that as we increase the desirability of one variable, we increase the desirability of other. A positive relationship means that as increase in desirability of one variable is related to an increase in the desirability of another. The trade-off matrix, the roof of house is put through trade-off matrix, shows how each product characteristics is related to the others. What trade-offs we need to make. Setting targets. The bottom row of the house is the output of quality function deployment. These are specific measurable product characteristics that have been formulated from general customer requirements. All right, we have here the quality function deployment details, process used to ensure that the product meets customer specifications. You have here the voice of the customer, voice of the engineer, and the customer base benchmarks. All right, so we also have here adding trade-offs, targets, and developing product specifications. Okay, we can see there the trade-offs, the targets, and the technical benchmarks. We have here the 7 problem-solving tools, the cause and effect diagrams, the flow charts, the checklist, control charts, scatter diagrams, Pareto analysis, and histograms. Cause and effect diagrams, this is also called as the Fishbone diagram. It's focused on solving identified quality problem. All right, so we have, for example, there the head of the fishbone, which is the quality problems, and we have the different causes or causes of this problem. Okay, it could be suppliers, workers, machines, temperature, process, or material. A general cause and effect diagram. Okay, here's an illustration here. We have the quality problem. We look into the possible problems through different areas: machines, workers, suppliers, environment, process, and materials. Until we come up to the generalization, what's really the cause of the problem, and there we'll be able to solve that particular problem. We have the flow charts. It is used to document the detailed steps in the process. Often the first step in process reengineering. So we have here a diagram, example of flow chart. Checklist. Simple data checkup sheet designed to identify type of quantity problems and its workstation, per shift, per machine, per operator. So for example, here we have a defect type, broken zipper, ripped material, missing buttons, and faded color. And we are going to identify the number of defects and we try to get the total. Control charts, important tool used in statistical process control. The upper curve limit and the lower curve limit are calculated limits used to show when process in or out of control. You have UCL and down you have LCL. Scatter diagrams, a graph that shows how two variables are related to one another. Data can be used in a regression analysis to establish equation for the relationship. Also, the Pareto analysis, the technique that displays the degree of importance for each element, named after the 19th century Italian economist Pareto, often called an 80-20 rule. Principle is that quantity problems are the result of only a few problems. 80% of problems caused by 20% of causes. Histograms, a chart that shows the frequency distribution of observed values of a variable like service time at a bank write-up window, displays with whether the distribution is symmetrical or normal or skewed. Reliability, the probability that a product or service or part will perform as intended. The product is guaranteed with 100% certainty to function properly. High reliability is an important part of customer-oriented quality. The reliability of a product is a direct function of the reliability of its component parts. If all the parts of the product must work for the product to function, then the reliability of the system is computed as products of the reliability of individual components. Reliability. The more components a product has, the lower its reliability. The failure of a certain products can be very critical. One way to increase product reliability is to build redundancy into product design in the form of backup parts. Redundancy is built into the system by placing components in parallel. When components fails, the other takes over. RS, the reliability of first component plus reliability of second component times probability of needing second component. Process management. A quality product comes from quality process. Quality at source. It's the belief that it is best to uncover the source of quality problems and eliminate it. Managing supplier quality. The philosophy of total quality management extends the concept of quality suppliers and ensures that they engage in the same quality practices. If suppliers meet quality standards, materials do not have to be inspected upon arrival. Quality awards and standards, we have Malcolm Baldrige National Quality Award, the naming prize, the ISO 9000 certification, and the ISO 14000 standards. MBNQA, what is it? Award named after the former Secretary of Commerce, Reagan administration, intended to reward and stimulate quality initiatives. Given to no more than two companies in each of three categories, manufacturing, service, and small business. During the past years, we have the past winners, FedEx, 3M, IBM, the Ritz-Carlton. Typical winners have scored about 700 points. All right, so we have the MBNQA criterion categories. We have leadership, that's 920 points. Strategic planning, 85 points. Customer and market focus, 85 points. Information and analysis, 90 points. Human resource focus, 85 points. Process management, 85 points. And business results is 450, a total points of 1,000. The Deming Prize given by the Union of Japanese Scientists and Engineers since 1951, named after W. Edwards Deming, who worked to improve Japanese quality after the World War II, then opened to foreign companies until 1984. Florida P&L was first U.S. company winner. ISO standards. The ISO 9000 standards, certification developed by International Organization for Standardization or ISO, set up internationally recognized quality standards. Companies are periodically audited and certified. In ISO 9000, 2000 QMS, the fundamentals and standards, ISO 9001, 2000 QMS requirements, ISO 9004, 2000 QMS guidelines for performance. More than 40,000 companies have been certified. ISO 14000 falls on the company's environmental responsibility. Why total quality managed efforts fail? It may be because of lack of a genuine quality culture, lack of top management support and commitment, and over and under reliance on SPC methods. Thank you, and maybe all have a nice day.